Can you guess how tiny the smallest part this desktop CNC can carve actually is? We're going to take on a challenge, machining parts from bigger to smaller, all the way down to an incredibly tiny size. No matter the size of the parts, precision stays within 0.02 mm resolution. Even the tiniest, most extreme parts stay super precise, so every single piece works perfectly. Can you guess how tiny the smallest part this desktop CNC can carve actually is? We're going to take on a challenge, machining parts from bigger to smaller, all the way down to an incredibly tiny size. No matter the size of the parts, precision stays within 0.02 mm resolution. Even the tiniest, most extreme parts stay super precise, so every single piece works perfectly. Can you guess how tiny the smallest part this desktop CNC can carve actually is? We're going to take on a challenge, machining parts from bigger to smaller, all the way down to an incredibly tiny size. No matter the size of the parts, precision stays within 0.02 mm resolution. Even the tiniest, most extreme parts stay super precise, so every single piece works perfectly. Can you guess how tiny the smallest part this desktop CNC can carve actually is? We're going to take on a challenge, machining parts from bigger to smaller, all the way down to an incredibly tiny size. No matter the size of the parts, precision stays within 0.02 mm resolution. Even the tiniest, most extreme parts stay super precise, so every single piece works perfectly. Can you guess how tiny the smallest part this desktop CNC can carve actually is? We're going to take on a challenge, machining parts from bigger to smaller, all the way down to an incredibly tiny size. No matter the size of the parts, precision stays within 0.02 mm resolution. Even the tiniest, most extreme parts stay super precise, so every single piece works perfectly. Can you guess how tiny the smallest part this desktop CNC can carve actually is? We're going to take on a challenge, machining parts from bigger to smaller, all the way down to an incredibly tiny size. No matter the size of the parts, precision stays within 0.02 mm resolution. Even the tiniest, most extreme parts stay super precise, so every single piece works perfectly. Can you guess how tiny the smallest part this desktop CNC can carve actually is? We're going to take on a challenge, machining parts from bigger to smaller, all the way down to an incredibly tiny size. No matter the size of the parts, precision stays within 0.02 mm resolution. Even the tiniest, most extreme parts stay super precise, so every single piece works perfectly. Can you guess how tiny the smallest part this desktop CNC can carve actually is? We're going to take on a challenge, machining parts from bigger to smaller, all the way down to an incredibly tiny size. No matter the size of the parts, precision stays within 0.02 mm resolution. Even the tiniest, most extreme parts stay super precise, so every single piece works perfectly. Can you guess how tiny the smallest part this desktop CNC can carve actually is? We're going to take on a challenge, machining parts from bigger to smaller, all the way down to an incredibly tiny size. No matter the size of the parts, precision stays within 0.02 mm resolution. Even the tiniest, most extreme parts stay super precise, so every single piece works perfectly. Can you guess how tiny the smallest part this desktop CNC can carve actually is? We're going to take on a challenge, machining parts from bigger to smaller, all the way down to an incredibly tiny size. No matter the size of the parts, precision stays within 0.02 mm resolution. Even the tiniest, most extreme parts stay super precise, so every single piece works perfectly. Can you guess how tiny the smallest part this desktop CNC can carve actually is? We're going to take on a challenge, machining parts from bigger to smaller, all the way down to an incredibly tiny size. No matter the size of the parts, precision stays within 0.02 mm resolution. Even the tiniest, most extreme parts stay super precise, so every single piece works perfectly. Can you guess how tiny the smallest part this desktop CNC can carve actually is? We're going to take on a challenge, machining parts from bigger to smaller, all the way down to an incredibly tiny size. No matter the size of the parts, precision stays within 0.02 mm resolution. Even the tiniest, most extreme parts stay super precise, so every single piece works perfectly.
All right. Hello, everybody. It's great to see you all. Sorry about the extra loop there, but congratulations for joining us for another live stream. It's so good to have so many people from all over the world with us. If you haven't already said so, let us know from where you're tuning in from. My name is Jason Erdreich. I'm the education director here at Makera. And what that lets me do is essentially work with all of our awesome customers and users to help them learn how to create cool things with CNC machines, as well as work with all of our schools and universities and things like that too. Normally, I'm joined by my good friend Roloff, but he's not going to be with me tonight because he and his wife just welcomed a beautiful baby girl into the world. So huge congratulations to Roloff and his whole family. And we're just going to be hanging out together here, folks. So thank you again for joining us to another live stream. This one is sort of a celebration, hangout, Black Friday, etc. Right? So the goal is to kind of go over some cool, exciting new things we have going on. We have, of course, the Z1 that's still on Kickstarter. We have some competitions. We have some giveaways. We have some deals, some prizes, all that fun stuff. And also sharing some tips and tricks and answering some questions. So the goal is that while we're hanging out tonight and while we're celebrating some of the cool things happening at Makera, I'm going to take some time to answer your questions that you drop into the chat. Also show you some cool tips and tricks and kind of go over what I often train people how to do and some of the biggest challenges we see people face as they're learning how to use CNC machines. And then we'll see what else we have time for. So anyway, again, thanks for joining us. I'm keeping an eye on the chat, and I also have some other team members who aren't on camera with me, but they are online, and they're going to be answering some questions here in the chat too. So definitely throw your questions at me. If I don't have time to answer them live, I'm sure my team will do their best to do the same. So that said, I guess let's kind of talk about some exciting things. First and foremost, we're coming up to a lot of different holidays right now. Black Friday, Cyber Monday are on the way, and we do have some different Black Friday promotions that are happening right now, lasting until November 30th. So you can save up to $1,298 upon the purchase of the Carvera or Carvera Air. Depending on what packages you get, there's different savings for different things, whether you get just the machine or the machine and the fourth axis, or the fourth axis, the laser, whatever it is, but up to $1,300 off. On top of that, right now, it's 10% off all bits, accessories, and spare parts in our store as well. So you can get 10% off on all of that. And there's also 15% less impact on point reduction, which means that if you're using Makera Points to purchase some of these things, they're going to go 15% farther during Black Friday deal too, which is pretty cool. And we'll definitely talk more about some Makera Point stuff as we go through and get through some of our prizes and giveaways. Also, something super exciting is we have a special promotion specifically for all of our stream viewers too, which is actually a free essential milling bit bundle with the purchase of a machine. So that's a pretty cool custom coupon code. Let me actually show you guys how to do this because it's not as simple as just punching in the code. So I want to make sure you guys know how to get this essential milling bit bundle. So the code is Black Friday. Let me throw my screen up. Let's go shopping together here, folks. Let me find the right screen. Where are we? Makera. Here we go. Cool. So if you guys can see this. Yep, here we are. So let's say I want to buy a machine, right? Carvera Air. I don't know. Let's say I'm going to get myself a Carvera. As you can see, quite some good savings right now. All right. So I'm going to go ahead and add this to my cart. And then let me say I also want to get this essential milling bit bundle at no cost, right? So if we head down to our CNC bits and throw ourselves into this essential milling bit bundle, we're giving all of you the 26-piece milling bit bundle at no cost. So I think this is, $120 normally. It comes with 26 different bits, some common ones. We'll also be looking at bits and feeds and speeds tonight too. So we'll be talking about what these bits are and all that stuff as we go through our stream. But anyway, let me add this to my cart, and then let's go and actually check out here, right? So if I check out and if I enter our special discount code, Black Friday, let me make sure I spell it correctly. Here we go. You should see that this milling bit bundle is now free, right? So that's how you can go ahead and use that. If you want to get yourself some free bits, feel free to do so, which hopefully you guys enjoy as a nice special promotion as we go on here. Now, while I have the screen nice and large, let me go ahead and let's talk about the Z1. Some exciting things here. Let me switch to this tab. First off, 5,209 backers in counting. I'm seeing some questions. Does this milling bit bundle work for the Z1 as well? No, but we have other Black Friday promotions and things like that that works for the Z1 on Kickstarter, which is super cool, right? So first off, huge thank you to the 5,209 people that have chosen to back us thus far. This Kickstarter is without a doubt, obviously our biggest yet, but also I think one of the most exciting is it means that we're putting the types of CNC production stuff that we're super excited about into the hands of so many other people. So really excited about this. And as mentioned, there's some cool things going on with the Z1. We do have a bit of a Black Friday fest for the Z1. So here's how this works. We are giving out 4 special Black Friday prizes to all of our backers, which means that if you backed us already, you're eligible for getting all these prizes. And if you're deciding to back us and you choose to, you can get some of them as well. So here's how this works. Essentially, you'll see that we're revealing things each week all the way up to Cyber Monday, right? Every single week, there's a new prize that's given out here. And depending on when you pledge is depending on when you're going to get those prizes. So if you're an early person, meaning that you pledged before November 18th, you're getting all 4. Awesome job. If you pledge before November 25th, you're getting these 3. Before the 2nd, you're getting those 2. And before the 9th, you're getting one of those prizes, all as part of our Black Friday promotion. There's no extra cost. You just get it for free with whatever that you chose to pledge, which is super awesome. And as you can see, we haven't revealed all the secret prizes yet, so you're still not sure what we're going to give away the last 2. But you'll notice that the first one was the free side clamp kit. And then the second one is the taller L bracket for the alignment bed. And we'll have to kind of wait and see what those last 2 prizes are. But of course, there's still time to take advantage of that. But listen, there's some other exciting things. We've been hitting our milestones, right? In fact, I think we're super close to hitting our last milestone. Let's find out this together here, folks. The Z1's a super awesome machine. I have mine, where am I? Behind me here, right? We're going to be getting hands-on with it a little bit later tonight. We have so many cool reviews. We're super fortunate. There's been so many makers and YouTubers that have done some awesome projects with all over the world. So definitely check that out. I'm trying to find our unlock stretch goals, right? So what that we've already unlocked is that we've created these MDF spoil boards, which is super cool. We'll talk about what those spoil boards are as we go through some of our tips and tricks tonight. So we unlocked that, which means we're getting these spoil boards, which is fantastic. And we just hit our 3D probe rod, and I was just sent one from the factory. So I've been playing with one, which is super cool. And we're going to talk about what this does for you and how to use this when we get into some 2-sided machining and things like that, tips and tricks in tonight's stream. So we just unlocked that, which is pretty cool. And lots of other cool, exciting things, right? We can machine different metals, high levels of precision, some really awesome software updates and intelligent control, and some really cool stuff, right? So we are, again, beyond excited for the launch of this machine, some different accessories. If you didn't check out last stream, Rolf and I actually unboxed one of these guys and got it up and running. So we looked at some of these accessories, like the 4th axis module, which is a new module specific for the Z1. It's a little bit smaller, but works very similar to the other ones that we have for the Carvera and the Carvera Air, a belt-driven 4th axis module like so, and also the laser module, this guy, right? And this is the exact same unit as what's available for the Carvera Air, right? So it's the same laser module that just inserts right into the spindle for you guys to be able to do laser engraving with your Z1. And also our dust collector light, which is a slightly smaller, slightly less powerful, but still excellent cyclone dust collection system that's well suited for the Z1 and can also be used for air filtration with laser engraving as well. So lots of exciting stuff. Again, a huge thank you to all of our backers thus far. We are pretty excited to be launching this new, smaller entry-level CNC machine that's still super, super capable for everybody, but also really geared to be more accessible for makers that want to get into CNC machining, right? So let's see. I don't think we're missing anything here. Concepts, all this some stuff. I did see one question was thrown out in the chat before we started, which was what's our estimated retail? And I believe it's $1,199, $1,200 US. Where is that? Let's see. I think that's on here somewhere. Let's see. Yeah, here we go. $1,199 is our current estimated MSRP retail. So that was a question that was thrown out into the chat before we went live. So super exciting stuff. And again, thank you everyone who's already backed us. I saw some cool folks that were dropping in their backer number. So we appreciate all you guys. Really appreciating all of your support with that. So let's see what else we have going on. I'm looking at the chat. I see definitely throw some different questions here. One question that popped up right now is the difference in bed size, right? So the Z1 bed is square. It's a square bed where the Carvera and the Carvera Air bed are rectangular as we go through. In terms of the actual bed size, I know it's around, I was going to say in inches, but I'm going to give you guys both inches and millimeters. It's 200 millimeters square, or about 7.9 inches square for the Z1, where the Air is a little bit bigger. Let me again get you the global. I apologize that I'm not like super well versed in all of my global dimensions. And sometimes when I just say inches, I lose people. And sometimes when I just say millimeters, I lose people. So I'm going to give you guys the full breakdown here. So like I said, the Z1 is 200 mil square, or about 7.9 inches square, where the Air is 30 centimeters by 20 centimeters, or 300 centimeters by 200 centimeters, which is about 11.8 by 7.9. So essentially, the depth of the Z1 is the same depth as the Air, but the Air is a little bit wider as you go through, a couple inches or about 100 mil wider as you go through. So solid question, of course, and I'm going to keep trying to answer your questions to my best ability as we run through. All right. Now, another cool thing that we have going on right now is we have our second community contest, which I'm super excited about. Community contest is the second one that we're running here on our Reddit page. And this is, anyone can participate, right? It's fostering collaboration and conversations in our maker community. And anyone can participate as you want to go ahead and collaborate with us. The theme of this contest is called Why CNC is for Me. And what we really want to know is we want to hear your CNC story. We want to hear how you got into CNC machining, what you do with your knowledge of CNC machining, whether that's mills like we make, routers, big industrial machines, whatever it is. We want to see what you do, and we want you to collaborate and share awesome creativity and leadership and inspiration with other creators. And we want to give you awesome prizes for sharing that. So this is on our Reddit thread, which I think I have the ability to pull up here. I am kind of, single solo DJ here tonight, but I think I'm doing all right. So here you go. Why CNC is for me. It's a contest that's running through the next couple months here. You can win up to 30,000 Makera Points, which is a $300 value. And we haven't actually said how many prizes we're giving of each because it's going to change. The more people we enter the contest, the more prizes we're going to give out. So we're hoping that we get a lot of folks that want to collaborate and share their story on Reddit. And if you're wondering like what you could share, it is truly as open-ended as it sounds. I mean, we want to hear your CNC journey. We want to hear what you do with CNC machining. But we did offer some questions like what sparked your interest in CNC machines? Did you work with other things like 3D printers or lasers before you got into CNC machining? What was your first aha moment that kind of made it sink in for you? You know, do you have a Makera machine? What do you like to create with them? What materials do you like to use? So these are some questions. You don't have to answer all of them in your response, but some questions to guide what you're going to share. And again, we really want to make sure that you are giving users a chance to collaborate with one another, right? That's our goal here, is that we want to see you guys collaborating, sharing cool things. When we did our creation contest some point over the summer, it was awesome. People shared projects, they shared how they made it, they shared some photos, videos, and it was such a cool way to collaborate with so many makers in our community, and we're hoping that we can do the same. I know that my CNC journey was a little all over the place and definitely hesitant, that I started with some big industrial machines. When I became a teacher, I couldn't bring those big industrial machines into my classroom. It just wasn't feasible. They were far too expensive. I was in a tiny middle school when I first started teaching. So I was really focusing on 3D printing. And it wasn't until more intuitive machines like this came out that let me bring big level manufacturing concepts into my classroom, which, you know, it's been an exciting journey for me. And I'll definitely make sure that I share my story in there too. So let's see, that's a lot of cool stuff. I think that's, you know, our sales that we're talking about, some exciting things with the Z1, exciting things with the contest. Definitely make sure you guys take some time to look up that. And there's a nice little video that shows you the different judging criteria and all that. But again, we really just want you guys to collaborate and hear what you have to say. And I think let's pause and do a giveaway, give away some prizes. We're going to give away a few. So here's what we got going on here. In case you're new, whenever we do these streams, we like to give stuff away. And this time around, we're going to be giving you Makera points that you can use for all of the Black Friday sales, promotions, and deals that we have going on right now. And as mentioned, it's 15% less deduction right now, which means that these points are going to go 15% farther with whatever that you choose to purchase them with. Now, in case you're new or you haven't heard this before, what are Makera points? Well, essentially, we want to reward you for being an awesome user and creator and, you know, supporting us like we support you. So there are tons of ways to earn points. You can get them during live streams. You can get them from referring friends. You get them from purchasing things in our store, from, you know, following us in Instagram. You get them for participating in Reddit contests. You get them for participating on Makerables when that comes out, meaning that if you post a project, we give you points. So lots of cool ways to get points as you go through, and you can use them for lots of stuff. You can use them for gift cards. You can use them for a hat. You can use them for accessories and bits. So you can basically put them towards any type of purchase that you'd like to do within our store as you're getting stuff. So let's give some points away. Now, here's how this works. First off, to enter this stream, you have to be commenting on either Facebook or YouTube. Those of you that are tuning in on Instagram, thanks for being here. But Instagram comments cannot participate in our giveaway tool. So you have to make sure that you are watching us on YouTube or Facebook to participate. Essentially, I'm going to give you a keyword, and you're going to enter that keyword, and I'm going to do a lucky draw, and I'm going to draw a bunch of people, and then you're going to get a thing. You also have to follow us on social media. So you have to follow us on whatever you're watching, whether you follow our Facebook page or YouTube channel, make sure that you're a follower. If you're not already, do that now. Somebody just said, what about MySpace? Those were the times, right? I appreciate you. Thanks for saying that. But no, whatever current social media you're on, please make sure you follow us. And then if you are a winner, I'll tell you how to get your prize after we go through some prizes here. So the first giveaway is going to be 3,000 Makera points, which equates to a $30 value, not including our current promotions. They'll let that go a little farther. And the keyword is, get your keywords ready here, folks. Your keyboard's ready. The keyword is hashtag Z1, capital Z. Ready, steady. Oops, sorry, let me show you the screen. Ready, steady, go. And I've also never done this before. This is usually roll-off's job. So let's see if I didn't mess this up. Hey, it's working. All right, good job. I can give out stuff. Woo! It's normally roll-off does that. So I was a little worried about this working, but looks like I can handle this. Awesome stuff. So yeah, hashtag Z1, make sure it's capital Z. I see some folks are trying to enter more than once. I appreciate you, but only one entry counts. But yeah, let's see how many we get here. This is just the first giveaway of the stream. I have lots of things to give away as we go through here. But we'll see how many folks enter, and I'll see how many of these 3,000 point giveaways I can offer to you here, folks. So keep it coming. Keep it coming. Let's see. We're hitting almost 200, which is awesome. Let's see how we go here. Looks like we have about 380 something people with us. So how many people want to enter? I'll give you guys another few seconds. And then we'll do some draws. All right. Last few entries. Looks like we're slowing down. And here we go. Who's going to be the first winner of this stream? You can keep entering while I'm going here. Ready, steady. Trosuma, congratulations. You're the first winner of this live stream. You just won 3,000 Makera points. But I'm not going to stop there. I'm going to pick 5 people to get 3,000 points. So let's keep it coming. Here we go. Next winner, you can still enter if you haven't already. Hashtag Z1 if you have not already entered. Jason H3635, you have the coolest name ever, and you just won 3,000 points. Way to go. Let's draw again. Here we go. Third winner. Barbara Giles, X7K, congratulations. You just won again. So we have 3 winners. Let's keep it coming here, folks. 3,000 Makera points going to all these people. Ready, steady. And MG, M. Goretz, I think, maybe. I apologize if I'm butchering everyone's name. I'm sorry, but you just won 3,000 points. So congratulations. And one more winner just for now. We're going to do some more drawing. So if you're not this next winner, stay with me here. I have plenty more prizes to give out, but one more winner, and it's going to be Harry Albert, 6728. Congratulations to those winners. You all just won 3,000 Makera points. So here's what you got to do in order to get your prize. Again, 2 things. First off, make sure that you're following us on whatever social media channels you are on, right? Whether it's YouTube, etc. Subscribing, following, go with that. And then you have to email your account info. So whatever your username is on, again, whatever it is that you're on right now, to info@makera.com so we can verify that it was you that just won the prize. And because these are digital prizes, we will send you your points via your Makera Club account. So then that way you have 3,000 points that you can use to buy awesome stuff. So again, congratulations and thank you for those first few winners. But again, if you didn't win, don't be too disappointed. I have plenty more prizes to come as we progress through this stream here. So let's talk about what we're doing, right? Tips, tricks, hangouts. So first off, please throw me questions. My chat is kind of all over the place with all those hashtags, etc. Right? So send me questions if you have them. I'll do my best to answer them if we can pull them into the stream. I have a couple different tips and tricks on what common challenges, confusion, things like that our users go through whenever I'm doing the training and whenever I'm helping folks learn how to do CNC machines. And I'm going to try to break some down and share them with you. The first one I want to talk about are bits and feeds and speeds. So incredibly important stuff. If you're new to CNC machining, CNC machines are computer numerically controlled machines. To be super clear, there are tons of different CNC machines out there. 3D printers, well, we don't call them CNC 3D printers. They are CNC machines. They run on a coded G-code file, just like our milling machines. There's also routers, lathes, wire EDM, water jet cutters, plasma cutters, whatever, right? Specifically right now, we're talking about subtractive manufacturing CNC machines like our milling machines, the Carvera, Carvera Air, and Makera Z1. So whenever you're using a machine like that, you have some type of cutting bit like this. Let's see how good my autofocusing camera is. Not very, Find the bit. All right, sorry there, guys. Anyway, bits. So you have this cutting bit that spins very, very fast, and this is used to remove material. Couple important factors to get success with your CNC project. You have to choose the correct bits for what you're doing, and you have to use the correct feeds and speeds. So let's talk about bits first, then we'll talk about feeds and speeds. And again, throw a question with me if you have some questions here, and I'll go back and I'll answer some questions as we go. So how do you choose the bits? The first thing is material, right? So there are bits that are made for metals, like hard bits, right? That are designed for harder materials like metals. Then there are bits that are made for softer materials that aren't metal, right? If you're working with plastics, typically plastics, woods, epoxies, all of those softer materials can use the same type of bit. If you're working with metals and if you try to use a wood bit, it's not that it won't work, but you'll probably wear the bit incredibly quickly and you're probably going to break the bit because it's not designed to handle that. So it's certainly not going to last as long as it would if it wasn't designed correctly. And then there's also some type of materials like carbon fiber, fiberglass, PCBs that are very abrasive. And those are really good at dulling bits. So you want to use the right type of bit that, again, it's not like you can't use any bit you want, but if you don't use the right bit, you're not going to get a clean cut and you're just going to kill your bits. You're going to wear them out. They're going to dull incredibly quickly. So choosing the right bit for the right material is important. I typically recommend people that if you're like me and you kind of make a ton of different stuff with a ton of different materials all the time, buy more metalworking bits than non, because a harder bit for metal is maybe a little bit more expensive, but there's no reason why you can't use that for, let's say, a softer material as you go through, as you go here. So that's pretty cool. And then the other thing to think about is if you are choosing your bits, you choose it for the material that you're working with, and then also the type of cut that you're creating, right? So what I mean by that is you'll notice that you have bits that we call flat end mills, ball nose bits, V bits, etc. What do those do for you, right? So a flat end mill, and we're going to really be challenging my camera here, is this. This is a single flute spiral O flat end mill, and personally, my favorite bit. Basically, what this is describing is that the tip of the bit, like the very end, the cutting part, which is actually pointed down normally, is flat, like literally tabletop flat. What that does for you is it allows you to create flat cuts. Let's say I want to create, a pocket, a hole in my material that has a flat bottom. Okay, it will actually create a flat floor. If you ever used a drill bit, like on a quarter drill or a drill press, you'll notice that they have almost like a V shape at the bottom, right? Like a chisel shape. That means that if you drill a hole, it will never be flat at the base. It always has like a bit of a bowl, a V. Flat end mills give you an actual flat floor, which could be important depending on the type of hole or pocket that you're creating. Then you have things like the whole spiral O single flute. Well, this helical shape is a spiral O, and it's really, really good for evacuating chips. So if you have this lovely helical spiral O shape, as you're cutting, all those chips are pulled up and out and away from your part, which makes your cuts a little bit cleaner because you're not sort of grinding the chips into your parts, which is cool. And it also makes for a cooler cut because the chips get super hot. That could break your bit. That can dull this down, So you want to get those chips out. You want to evacuate the chips. That's usually what causes a lot of failure, is keeping those hot chips in. That's why we recommend using air assist if you're using metal, or the aerodust system of the Z1, right? So why do I like this one so much? Because it's excellent for cooling. It's flat, so it can give me a nice flat base. It can do a lot of different types of cuts. It can do pockets, like hollowing out parts. It can cut around the perimeter to separate parts like this, where you'll notice that my piece is cut away from the stock. It can even drill holes. So it's just a super versatile bit, and it comes in many, many different sizes, from kind of medium size to big size to, I don't have one. Oh, I do. Actually, haha. I was prepared. Tiny, tiny. Look at that one. Somebody asked, like, what's the smallest bit? I think the smallest bit we sell is 0.1 mil. So a 0.1 mil size bit, tiny. So super versatile, really great bit. That's the single flute spiral O bit. Now, what if you want to do some type of engraving? Okay, you want to make some type of fancy engraving. Let's see if I can get this close enough. There you go. Our little pirate ship sample. That's super detailed. That is not a flat base. That has lots of different contours in it, right? Well, then you need some type of engraving bit. And we really like using V engraving bits, V bits. These guys that have a very pointed end there, right? And these V bits can be used for engraving, whether that's engraving some type of 3D relief, engraving, text and things like that, whatever it is. And another type of engraving bit that you could use is a ball nose bit. So V versus ball nose, there's a lot of similar things. V bits are typically smaller. They're good for doing interior pocket cuts. Ball nose bits literally have like a rounded ball at the bottom, and they're good for making rounded, smooth curves. If you're making a lot of three-dimensional shapes, especially three-dimensional shapes in metal, ball nose bits are great. If you're trying to do really fine detail and high precision, V bits are great. We typically recommend, a little bit of both. It depends, again, on what types of materials that you're doing with as you go through. So those are really cool. And I think my fourth favorite bit, so of the 4 types of bits I use a lot, single flute spiral O, V bits, ball nose bits. My fourth is corn bits, like cobs of a corn. And that's this guy. This is a really funky looking bit. I hope that I can get my camera to focus. Maybe. Where am I? No, sorry guys. You can kind of see it. It's got a million little teeth, okay? Kind of like the cobs on a corn, right? The actual corn kettles here. And this bit is really, really good at working with extremely abrasive material. So we mentioned things like carbon fiber, fiberglass. That's really hard stuff. It's gonna like dull. I mean, it's basically like cutting sandpaper. It's gonna dull your bits really fast. If you're using a corn bit that has a million teeth on it, it's going to last longer, even if you're using a very tiny corn bit. So those are good for when you're doing some type of abrasive cuts. And like the single flute spiral O, you can use corn bits for pockets, outer cuts, drilling holes. It's a very versatile bit, and I like those a lot. I don't often use drill bits, which you might find surprising. And the reason I often don't use drill bits myself is because I end up using end mills a lot more. I will do a drilling operation with an end mill, or I'll do a pocket operation with an end mill. Like if I'm making a complicated PCB, a printed circuit board that has maybe 3 different hole sizes, instead of needing 3 different bits and 3 different bit changes, I'll use a corn bit that's smaller than my smallest hole. Let's say I'm doing a 1 mil, a 1.5 mil, and a 2 mil hole. I might use a 1 millimeter corn bit and then actually cut those holes as pockets. So I only have to do 1 tool change and I only need 1 bit. It's not that I don't ever use drill bits. Drill bits are definitely handy for a lot of different things as you go through. But of course, it's I find that I like using the more versatile bits as we go through. I'm also seeing some questions about the different in flutes, right? Like single flute, 2 flute, 3 flute, 4 flute, etc. The flutes are sort of these shelves, these spiral shelves, these cuts in it. Like think about a drill bit. If you've seen a drill bit that has like the helical cuts that go around, right? Each of those cuts is considered to be a flute. What the flutes do is they, as I mentioned, they pull the chips out, essentially. They guide the chips away from your cut as you go through. More flutes gives you higher cooling, right? It can do better to pull cooling away, but it also reduces the amount of surface area that you have for actually doing the cutting. So typically you can't necessarily remove as much material on this as you go through too. So there's pros and cons. A single flute is a very efficient bit for both cutting and cooling. A multi-flute, like a 2, 3, 4 flute, might give you better cooling, but not as much cutting material or not as much material removed per pass. So there's a lot of compromises. You typically won't find like 2, 3, 4 flute bits when you're working with 1/8-inch bits like this, 1/8-inch shank diameter bits. You typically have to go up to bigger bits like 4, 6, 4/6 mil, or 1/4-inch bits that are a little bit bigger to be able to have more flutes, which is kind of cool. So those are your bits. Now, let's also talk about, I just talked about bigger bits. Here's a cool thing that you might not have noticed if I head back to our store. This was a major request that we got, and we're super excited that we could do this, is you'll now notice, if we head back over the store, go to CNC Bits, that we now carry a lot more bits that are not just 1/8 inch or 3.175 mil. We now start carrying bits that are 4 mil and 6 mil in diameter, and we plan to add more as we go. So we're now selling some larger bits in our store, and like everything, if you click on any of these bits, you can of course not only see the materials that it's for, what they're designed to work with, and also your starting feeds and speeds, which is super cool. Now, while we're talking about this, let's talk about what feeds and speeds are, right? A couple different things. We talked about what bits are and why you might choose a different bit for a different cut. And I should point out that we have a lot of videos on this, on how to select the right bit and things like that. And whenever we do a full length project, where we show you how to make something from start to finish, we show you which bits that we choose. So let's talk about feeds and speeds. Feeds and speeds basically describe how fast the CNC is machining as it's creating your part. Whether that's a cutting speed, as if it's how fast it's moving as it's cutting your part, or a travel speed, how fast it's moving while it's not cutting your part. And there's a couple different key things. You have your RPM of your spindle. So that's how fast the spindle is moving. Typically, with harder materials like metals, you spin faster than softer materials like wood. And we often find that we're running somewhere between 12,000 to 10,000 RPM or so. 12,000 RPM for metals, 10,000 RPM for softer materials in general works really well for our CNCs. I have some bigger CNCs that actually only spin at 5,000 RPM. So it depends on the type of mill that you're using, or whether you're using a mill versus a router. So that 10,000, 12,000 RPM isn't necessarily universal to every CNC. You have to kind of determine what milling spindle hardware you're using to figure out what the right RPM is. But in general, we usually operate somewhere around 12,000 RPM. Then you have your cutting speed. So that is your actual, like your feed rate here. And then you actually have like your speeds when you're, let's say, moving down. So your depths of pass. So you have a lot of different things here. Your cutting speed will determine, of course, how big your bit is and what material you're cutting. So harder materials like metal, you have to cut more slowly than softer materials like wood. And then also your depth of cut, right? So the harder material that you remove, the less material you can remove at a time. So we call that our depth of cut. Sometimes we refer to that as our step downs. So for example, a nice soft material, I can take big step downs and remove a lot of material per pass. A harder material, smaller step downs. Also, the bigger bit you use, the more cutting surface area it has. So therefore, the more material you can remove at a time, right? If I'm using a bigger bit, I can remove more material per pass than I can if I'm using a smaller bit. But of course, there's pros and cons. The trade-off is a bigger bit won't fit into as tight of a location. So therefore, you have to, if you're doing a very small, fine detail thing, then you have to use a nice smaller bit. But couple things. First off, we try to make this as easy for you as possible when you're learning this, because it can get a little complicated for sure. One thing to do this, if I send you over to this screen and throw us into Makera Cam, you'll notice that in our tool library, we provide the bits that we carry in our store, and we have to come out with a little bit of an update here for some newer bits that we recently added. And we offer all these feeds and speeds that we're talking about, the recommended cutting speeds, the recommended step downs, the feed rate, the plunge rate, etc. A couple different things here. The feed rate is sort of like the horizontal speed. So that's how fast it's moving as it's moving in a horizontal direction. The plunge rate is a vertical speed. So that's how fast it moves as it lowers into the part. And you'll see that we have these recommended for a wide range of materials. Aluminum, brass, and copper, you'll find use very similar numbers because they're similar materials. Plastic and woods use similar numbers because they're similar materials. So all these are kind of preset for you to hopefully get you on the right track as you're choosing your feeds and speeds. That said, though, note that these are a great starting parameter, meaning that this is not necessarily the fastest your machine can cut. It's not necessarily the most ideal for some really intricate, crazy, complex thing that you're trying to create. It's an excellent starting point. So we always recommend when you're doing a project for the first time, you're working with the material for the first time, you do some test cuts. So you try something out, you give it a go, you do a sample, you see how it works, and then you come back in your feeds and speeds and you make some adjustments and you change it. We always recommend that you start slow and then work your way up, make things move a little bit faster. So that way you don't dive in. And I mean, the most common things we get is people are breaking bits, which for the record is part of the learning process. You're going to break bits when you get into CNC machining. But we always recommend start a little slow, then increase your speed as you go, as you work on something. It's also cool that our tool library makes it very easy for you to modify. So let's say, for example, I want to edit the feeds and speeds, but I don't want to mess up like one of the preset ones. You can actually create your own group, right? So I can call my own group, and let me just move this. I didn't need to put this here. Let me put this down here at the bottom here. I can create my own group and make this like, I don't know, experimental group, something that I'm sort of trying. Not XO, sorry, guys, I can't type tonight. Experimental, EXP, as we go here. And then maybe I want to copy a bit from here. So I'm actually going to copy this guy. And then I'm going to come on over here and paste it. Now, if I want to edit this bit, I can change my numbers. I can maybe reduce my feed rate a little bit. I can reduce my plunge rate a little bit, or I can increase it. And I didn't necessarily change the original bit. I just made some minor changes for testing some things out as we go through. So always recommend that you start slow and work your way up. That's definitely a safer and more effective approach to doing this rather than starting fast and slowing yourself down. And I often find that one of the biggest numbers that causes some headaches with feeds and speeds isn't actually the spindle speed or the cutting speed. It is your step down and your plunge speed. So this is how much material it's removing per pass and how quickly it goes down per pass. So if you're going to slow something down, or if you find that you're breaking bits often, reduce your step down, reduce your plunge rate, and then gradually increase that, because that sort of is the biggest shock and wear on your bits as you go through. So feeds and speeds, choosing the right bits. Hopefully you found that helpful. Before we do one more giveaway, I saw some folks asking like, wait a minute, can you put bigger bits in the CNCs? That was a question that was thrown out here, right? The answer is yes. So let me switch to close cam. Let's see if this works. There we go, close cam. So here's my Z1, and by default in the Z1, we have an 1/8 inch shank diameter. So for example, I can reach around here and I can easily load my 1/8 inch engraving bit into my default spindle, right? Which is super cool. But what if I did want to use this nice big 6mm tool to remove a lot more material? Well, on all of our CNCs, you can easily remove the spindle collet. And the Z1 has this nice little wrench, which is a little bit different than the tool for the Air and the Carvera. And that lets you super simply unscrew the spindle collet and actually remove it like this. And this is the same collet in all of our CNCs. They are universal. All the CNCs use it. And you can buy bigger collets from the store. So here's a nice bigger collet that I can simply thread in like so in just a few seconds. Let me grab my wrench, tighten this guy up a little bit. And now my Z1 can hold this bit, right? So super simple. But another nice tip while I'm over here are these. These are bit collar adapters. And what they do, or bit shank adapters, I should say, is let's say in a single project, I want to use this big bit to remove a lot of material. And then I want to do some type of small detail engraving. Yes, you can remove the spindle collet mid-job if you'd like, or you can actually take these shank adapters, which will actually change the shank diameter of your bit. So I can drop this and insert this. And now using my bigger collet, I can actually use a smaller diameter tool. So that's pretty cool. So yes, you can totally utilize different size bits with all of our CNC machines just by changing out the collet as you go. So that's pretty cool. Let's see if I'm missing any questions here. Hang on, I got to scroll back up. Well, the collets, let's see. Yes, the collets available in the store today will work with the Z1. They are the same, universal for all of our CNCs. Let's see. Oh, we're glad you liked the fly cutter. That was pretty cool. Yeah, we're going to have a full-length tutorial on that one. We got a lot of questions when that came out, so that was a quick preview. So we're definitely going to show you guys how to do that a little bit more as we go. And let's see. So the max collet that we have is 6.35 millimeters, which might sound super random for all my folks who don't live in the US, but that converts to 1/4 inches or 0.25 inches. So that's a standard size here in the US. Our metric standard sizes are 3 mil, 4 mil, and 6 mil. Our US standard sizes are 1/8 inch and 1/4 inch shank diameters that you could put in. So I think that answers the questions there on the on my collets and on my feeds and speeds. And I think it's a good time for another giveaway. So let's get our keyboards ready here, folks. Let's do our second giveaway of the evening. If I can pull up my screen. Here we go. Cool. Now, this time, we are going to give away 6,000 Makera points, which is a $60 value. 6,000 Makera points. So here we go, folks. The keyword this time around is hashtag air, capital A. Ready, steady, go. Hashtag air. See what we got here. Oh, good. It's working again. Excellent. Love that. Hashtag air, 6,000 Makera points, which is a $60 value. Here we go, folks. Let's see. I'm just going back through some comments as we go. We got 186 entries so far. Let's keep going here, everybody. Let's keep going, keep going. How many can we get? Again, 6,000 Makera points, which equals $60 value. If you did win earlier, you could win again. That is possible. I know we have 5 winners so far, but let's see. Let's see. All right, I'll give you guys one more second as we go. And let's draw. Here we go. 6,000 points, $60 Makera value. And the first winner of this is TC3D It. Congratulations, you just won 6,000 Makera points. Let's draw again. Here we go. James Nicholson, 2431. You also just won 6,000 Makera points. Congratulations. And one more draw. Let's see. This is going to be whatever, 6th, 7th, 8th winner of the night here so far. Rysum, congratulations. You also just won 6,000 Makera points. So congrats to those winners. That is not the final giveaway. We have one more giveaway that we'll do in just a little bit as we go through here. So stay with me, folks. We will do one more in just a bit. Let's go see. Let me see if I missed any questions here. Again, if you have any questions, tips, tricks, strategy questions that I can answer, definitely throw them in the chat. I have a couple more things I want to talk about. But if there's things you want to hear about, definitely throw them my way. I'll do my best. And I also know that my team's online here to answer some more questions too. I did see some questions about that Black Friday promotion I demonstrated earlier. Remember, that's for the 26-piece milling bit when you purchase a machine right now for Black Friday. And I will demonstrate that for you guys one more time if you missed it later on as we go through. So let's see. Here's a good one. The Z1 is going to be your first CNC. First off, congratulations and thanks for backing us. Much appreciated. What are some accessories I should get, like sandpaper, deburring, etc., to remove tabs? I'm so glad you asked, because tabs is actually going to be my next tip and trick that we're going to talk about here. So what are tabs? Well, if you look at this piece, you'll notice that it's being held on to my part by these guys. And those are actually cut tabs, right? Why do we need this? Well, you start with a piece of material like this piece of epoxy or a piece of wood, a piece of metal, and you might just want to engrave that piece of material and that's your project. And then you take that out and that's cool. Like for example, sometimes you might put in a round piece of stock that's already cut to be a coin, you engrave it, and then you take it out. That's fine. But oftentimes you actually need to cut your part out of the stock. And because you have this cutting spindle, if you didn't secure that part, once you cut that perimeter all the way through, that part is going to eject. It's going to fly out. And fortunately, all of our machines are enclosed, so there shouldn't be any real hazards to you or your surrounding areas. but it could break your bits. It could cause damage to your machine. It definitely will ruin your part. So you want to make sure that you're using some type of tab to hold that in place. Now, do you need tabs? No. There are other ways to secure your stock and to secure your part other than tabs, and I will share that in just a moment. But tabs are definitely one of the more effective and more common ways to secure your parts as you're doing your CNC projects. So to that question we just got, what are some good tools that you should consider buying? Well, our sample kits come with this tiny little handsaw, and this guy works really well for soft materials like epoxy or for things like wood and some plastics. If you are going to be cutting tabs with, let's say, metal, this is not the most ideal tool. So some other tools I consider, my favorite saw to actually use for cutting tabs is called a coping saw. This comes from more like the woodworking space or jewelry working space. So coping saws are great. This is just a standard. This is not like a Makera product. You can just get these at pretty much anywhere. Coping saw with a C. These are really cool because you can get a wide range of blades with really coarse teeth, really fine teeth, metal, wood, etc. This is also nice because you have a really deep throw here, meaning that you can easily work it around a wide range of projects, and it gives you a lot of control. I find one of the most frustrating things to do when you're doing a project is you do this awesome thing. You have tabs, and then as you're cutting it, you accidentally cut into your part. So be careful with that. I find that the coping saw gives you a lot of really good security. And some of you are asking right now, like, how in the world do you get the blade around? Well, the cool trick about coping saws is you can actually take the blade off like this. Let me see if I can do this with one hand on a camera. I can't. And you can actually move the blade inside your part. So I can actually rope this blade in to my part like this through my material and then re-secure it to my saw. And now my saw is actually cutting on the inside. And I would demonstrate this, but it's kind of difficult to do with one hand on a camera. So I apologize there, folks. And we do have a video of me showing how to use that. So coping saws are great. Now, you might also want to use some type of electrical saw. So I would recommend some type of rotary cutter. This is a battery-operated rotary cutter, but these guys work really well. You can use a cutting disc, or they even make straight cutters, which are basically like end mills, and you can actually cut that apart. So this, you definitely have to be a little bit more careful with this. Always wear your safety glasses because these cutting wheels can sometimes shatter, and that can be dangerous. So use caution, but this definitely gives you more power if you're trying to cut tabs off of a lot of metal parts, but not necessarily more control. So you definitely need to balance time of cutting your tabs and control to give you the cleanest cut. Sandpaper is great. Sandpaper works really well for soft materials, but I also recommend you get yourself a nice set of files, like jewelry working or metal working files, which are basically kind of like sandpaper for metal. So that's really nice. And yes, a deburring tool is also cool. This is my little deburring tool, which is a little handheld guy. So these work well. But you can also put deburring cutters in a rotary tool like this and actually deburr with a rotary tool, which actually works pretty fantastic. You could even put our chamfering bit and use that as a deburring tool as well, which is super cool. So all good tips, really good questions. I'm also seeing some folks are asking, how can you actually create tabs? Well, you can create tabs pretty easily. If I open up a project here, see if I can pull something up without tabs already drawn. Here we go. Let me grab my screen. Yeah. Right. So here's a nice little relief. This is a project I showed in one of our tutorial videos a little while ago. It's my dog. So it's a 3D relief of my pup. But as you'll notice, I just have the relief cuts on this. I don't have the outer contour cut that would actually release this coin from my stock. So let's generate that. Let's create a 3D contour toolpath. I'm going to generate my perimeter, my contour around my object, which might take a minute, sort of a complex STL. And let's see, how far do I want to cut through my stock? Maybe just like 0.2 millimeters to cut all the way through. Let me make sure I'm using the right tool. You'll notice that my feeds and speeds for brass are automatically selected because I chose brass in my project. So that's kind of nice. I don't need to change anything, but just to be clear, we talked about feeds and speeds earlier. If I change something here, let's say I want to be more gentle and reduce my step down. That doesn't permanently change the feeds and speeds in the tool library. That just changes it for this specific toolpath. So that's a good way to be experimenting with your feeds and speeds. Anyway, I'm going to cut on the outside. Ramping is always a good idea. That will gently enter instead of just plunging straight down. And let's say tabs. So I'm going to clear tabs, and I can actually use either no tabs. I can draw them like one at a time custom, or newer versions of Makera can actually generate them and place them automatically. So let's say that I want them to be, I don't know, 5 mil wide by 1 mil tall. Maybe that's a little thin, 2 mil tall. And let's say I want 4 tabs, and that will generate them for me evenly spaced. And then if we calculate our toolpath, you'll notice that the tab area was missed. Here's a common mistake folks make with their tabs, that the tab starts from the bottom of the cut, not the part, right? So you'll notice that I said that I was going to go, how far? 0.2 past. Let's say that I went like 1 millimeter past, which is more than you need. You should not need to have to go a millimeter past your part. But let's say that I do, and I go a millimeter past. Notice that because I went a millimeter past my tab, my part, I mean, my 2 millimeter thick tab is actually a millimeter below my part and a millimeter above my part. So what's actually holding this part is only 1 millimeter of material. So that's a common mistake folks make, is they think that they made a nice chunky tab, but because they cut below their part, half of that tab is actually below the part and not even touching their part at all. So the tab ends up being a lot thinner than you think. So be careful with that. That's a super common mistake. Some folks are asking, what do we think is a good size for different materials and things like that? How do you make it work? This is sort of experimental, to be honest. You kind of have to find what works well. And it also totally depends on what tool you're using to cut your tabs. If I'm going to be using this tiny saw, I'm going to want those tabs to be as small as possible. If I'm using a rotary cutter, I'm not as concerned with that, right? So my personal experience and my personal opinion whenever I'm making tabs, I did write this down for you guys so I remember. I usually make them only about 5 millimeter wide, usually, unless I'm removing a huge piece of material, and then I might make those a little bit bigger. But typically I keep my widths about 5 mil for any project I'm doing. And then in terms of thickness, I usually keep them around 6 millimeters thick for soft materials, 2 millimeters thick for hard materials, or about half of the thickness of the part. So if I'm making a part that's 4 mil thick on average, I usually make my tab about 2 mil. That's a generalized thing, but that doesn't necessarily be perfect. That's just usually where I start, is I make my tabs about half the thickness of my part for soft materials, maybe a little bit thinner for harder materials. But what you have to be careful with is if you have, again, if you have slightly warped material and if you're not cutting evenly all the way through, then again, you might throw yourself off where you think you have a nice thick tab and then you actually don't, right? So just be cautious with that. But in general, I usually keep my tabs somewhere between 2 millimeters thick or half the thickness of my part and about 5 millimeters wide as a good starting point. But I kind of play with that as I go to make sure that I'm happy with it. But do you need to use tabs? No, not necessarily. You always need to secure your part. One of my favorite ways to secure my parts is double-sided tape. People were always super surprised to see how many things I actually hold with double-sided tape. I even hold metal parts with double-sided tape. You see, we do this a lot in our materials. This is the double-sided tape we sell in our store. It's really strong. It's pretty consistent with its thickness, which is important. And it's super easy to remove after the fact. So this tape is fantastic in my opinion. And the biggest thing to keep in mind though, is what you're sticking the tape to on the bottom, right? Here's what I mean by that. I might have a piece of metal. The tape is going to stick to this just fine. But if I put the double-sided tape on my super messy, super dusty MDF spoil board, it's not going to stick at all, right? I need to stick it to a clean surface. So we talked about wasteboards briefly. Wasteboard is the piece of material that you put below your part to sacrificially cut through. Whenever I'm using double-sided tape, I always use a nice smooth piece of wasteboard, usually polycarbonate or acrylic. So that way I can secure my part to this polycarbonate using double-sided tape. That bond is going to be so good, you're going to need some type of spatula to get your part up to actually remove it. And then you don't really need tabs. You do need to be careful that if you have a really small amount of surface area that you can't even get like the width of the tape on, then there's not going to be a lot holding your part. I've also used hot glue, where I've actually hot glued my part down to a piece of acrylic and then just used a heat gun to peel the hot glue off. That works pretty well too, depending on what you're using. And depending on the job, you might even be able to use screws. For example, my little fidget spinner here, this is a two-sided part, and I actually made holes for alignment pins. After I machine this engraving area, I can actually just put a screw straight through this hole and hold that part in place using a screw into my spoil board. And then I also don't need tabs. So there are a lot of ways, a lot of different ways that you can secure your parts. It does not need to be tabs. It can be double-sided tape and things like that as well. But just keep that in mind that you always need to make sure that you have some type of thing. Somebody just asked, won't vibration break the glue? I've never had that issue personally. I'm not going to say it can't, but typically if I use, again, not MDF, I'll use something like polycarbonate. I will put a nice high temp hot glue gun, glue it in place, make sure it's held in place really well, like put weights on it or clamp it down, let it cool, and then it actually cuts through. And it works well in some circumstances. I don't prefer the glue to the tape, but I've definitely done that a little bit from time to time as different things. If you don't want to use tabs, if you want to avoid it. So let's see. I think I got a lot of questions. Let's see. What do we got here? Chat's blowing up. I also appreciate my team. It's answering some questions. Yeah, heat will definitely affect the hot glue before. So you have to be careful. Like, I'm not saying I'm gluing in the cutting area. I'm gluing like in the middle of the part. So it's not going to be around a heated area. Some folks were asking about Makera Studio. Yes, these were Makera demos. Makera Studio, as you probably saw in our last stream, is going to be our upgraded new version of Makera Cam. Not just for the Z1, it's going to be for all of our machines, and we're super excited about this. It's going to have a ton of new features, a lot of great fourth axis features, all the stuff that you're used to in Makera Cam, like the tabs and the tool library and all that stuff is still going to be there. But during the last stream, I actually demonstrated this, which was the auto generation features for creating reliefs, where after I import a design, it will actually look at this part. Let me just fast forward. This is from the last week's stream. And it will automatically figure out what tools I need to use and tell me the tools, the right tools for the job to its best ability. You still might have to go in and do some modifying if you want to do something that's a little bit out of the norm. But in general, it will tell you the right tools that you need to use, like this. And it will then generate your tool paths for the whole part. So it will generate your roughing paths, your finishing paths, your contour tool paths. It can generate tabs for you and all that stuff automatically, which is all pretty cool. So really fast auto generation, and we are super excited about this. This is still in development, which is why I'm not really showing it right now. We have some beta versions internally that we're still testing and working through to make it as polished and as good as it can be, but we're still on track for releasing this by the end of the year. So sometime in the next month or so, hopefully that's what we're going to be talking about in our next stream as we go here. So yes, that is still coming, and it's all super exciting stuff that we're working on here. So definitely stay tuned for more on that. And as always, of course, it's going to be free for our users. So let's see where we're at here. We're almost out of time. We talked about feeds, speeds, tabs, securing stock, work holding, lots of tips and tricks, other cool things. Let's see if we have any questions here. Do you have to use Makera bits for auto generation toolpaths? No, it pulls from your tool library. So what's in your tool library, it'll pull. It basically pulls from assignments. Like, for example, if you're using bits, if you're using metal, it's going to pull from the metal bits. If it's using the type of bit that it is for the contours, you just have to make sure that your bits are assigned correctly. If it's, you know, for the material that you want, the type of cuts that it is. But it's going to pull from your tool library, which is super cool. What if you're going to do, let's see. How do you work with an odd shaped stock, like a circle, disc, or instead of a block or a square? This is such a good question. We don't really have time to dive deep into this just yet, but we have a couple of videos, and actually there's some really clever folks on our Discord that have showed this. I think one of the easiest ways to do this is to make some type of jig, especially if you're going to do this a lot. Let's say that you're going to engrave a lot of coins. Make yourself some type of round jig, like some type of vise that will actually hold on to that. So then that way you can reuse that repeated all the time. If it's sort of a one-off thing, there's a couple of different ways. Our scan margin feature will let you check the perimeter of your job. And I think the simplest, but maybe not the most intuitive way, is to simply measure over your offsets to see where you are, move your part there and use the scan margin feature to really check that you're in the right spot. But this is also where the new 3D probe can come into place. So this is the 3D probe that was just unlocked in our Z1 campaign. It is also going to be compatible with the Air as well. It has the exact same plug as the Air. And in the most updated version of the controller, when it comes available, you can actually use this to essentially be like an edge finder, a center finder, a pocket finder, all those cool things. So this is also going to be really nice, specifically if you're working with an odd shaped stock, like some round piece of metal, like a round brass piece of stock or something like that would work really, really well. So we're definitely going to be showing you how to use that in future tutorials now that we know that that's coming as you go. And let's see. Somebody's asking about the tool run out with the collet adapters. No, we don't. I haven't actually seen any issues with the actual spindle run out with the collet adapters. They're really nice. If you look at the collet adapters, they have almost kerf cuts in it, so it can actually give it a little bit of flex to grab in there. So the collet can actually get a really firm clamp, which is a very clever design. And that should prevent at least any additional run out than what you would automatically expect with this. And let's see. I think, yes, the center finder can also be used for round materials or holes, like interior pockets and things like that, which is super cool. All right, folks, before I completely run out of time, let's do one more giveaway. So get your keyboards ready. One final giveaway. Let me find my screen where we are. Here we go. Keyboards at the ready. This is so much easier when Roloff is here. I missed that guy. Ready, steady. Final giveaway. Last little bit, it's a point. It's going to be our biggest one of the evening, and it's going to be 10,000 Makera points, which equivalates to a $100 value. The keyword is going to be hashtag. Did anyone guess it? Hashtag. Hang on. Carvera. Hashtag Carvera, capital C, ready, steady, get your prizes. Here we go, folks. Hashtag Carvera. Final giveaway of the evening, 10,000 Makera points. $10,000 Makera points. Keep it coming in here. I'll give you guys another minute or so. We see lots of people coming in, which is great. 170 or so. Let it keep coming. Final giveaway. And again, you might be lucky. You might be able to win more than once. We shall see. You can also continue to enter even when we draw. Let's see how many folks we get. Hashtag Carvera. All right. Another second, and then I'm going to do it. Here we go. And draw. So who's going to get 10,000 points? $100 value. Here we go. Alpha Kilo Accord, you just won 10,000 Makera points. Congratulations. But let's do one more. One more draw. Final winner of the evening, 10,000 Makera points. I think this is our 10th winner of the night, if I'm counting correctly. 10 winners. Ready, steady, Shadow X 04K. Congratulations. You just won 10,000 Makera points. And again, a huge congratulations to all of our winners for this evening. As a quick reminder, to win, make sure that you're following us on social media. Make sure you screenshot your account info. Send that to info@makera.com so we can send you your points. So a big congratulations to all of our winners. Now, folks, hopefully you've enjoyed this hangout. It was a little bit more of a casual. I really enjoyed being able to flip through your questions, your comments, and things like that and answer. So hopefully you learned something and some new tips and tricks and things like that as we went through all of these different things here. As a couple key quick reminders before we close out, tons of different sales going on right now. So Black Friday sales until the 30th. You can save up to $1,298 depending on what you purchase. If it's a CNC machine like the Carvera Air, and the different packages that we offer, like the bundles with the 4th axis, the laser, lots of savings across all of that. It's also 10% off all of our bits and accessories and spare parts in our store. And again, a 15% point reduction, meaning that for those folks that just got some Makera points, that means that they're going to go 15% farther than they normally would during that Black Friday sale. I also, again, want to remind you what this code was for, this Black Friday code that I mentioned earlier, just to show you this is a special code specifically to get you a unique milling bit bundle with the purchase of a machine. So let's say that I'm going to buy myself the Carvera Air this time instead of the Carvera. I add this guy to the cart. And then I'm going to go find my essential milling bit set, specifically the 26-piece set. Add that to the cart. And now when I go and I check out, if I use the code Black Friday right here, which I already entered earlier tonight, but just to show you, if I enter Black Friday again, that milling bit bundle will now become free because I've also added a machine, either the Carvera or the Carvera to my cart. So that's a special live stream only promotion as we go. And I also noticed that we did get a couple more backers here for the Z1 during the live stream too, which is super cool. So thank you folks for continuing to expand our support. We're super excited about that. Really excited for all the new stuff that's coming with us here. So more to come with the Z1 as we go through, more tutorials as we talk about your the new 3D probe and all the cool stuff that we're dealing with, which is super exciting. So definitely stay tuned for that and Makera Studio updates. And also remember that our creation contest, our story and creation contest, is live on Reddit, where you can tell us your CNC story, and we want to give you awesome prizes for sharing and collaborating with other users on our Reddit channel. So remember to stay tuned with that, and we can't wait to hear what your CNC story is. So listen, folks, again, I hope you enjoyed this Hangout. Thank you for sending us the questions. If we didn't have time to answer your questions, I'm super sorry that we didn't get to you, but of course, find us on Discord, find us on our Facebook groups, find us on our YouTube comments, or of course, just send us an email. We're happy to help you learn how to do CNC machining. And again, a big congrats to all of our winners, and stay tuned until next time, everybody. Cheers, everyone. Thanks so much.